The creation of the heavy bomber TB-7, later named the Pe-8, became one of the main projects of Soviet aviation in the 1930s. Its development began when the Soviet Union sought to strengthen its military power, especially in aviation, to counter possible enemies. At the center of this story were the experimental aircraft AN-T-42 and AN-T-42 Doubler, which became the basis for future mass production. Work on these machines was carried out simultaneously with preparations for their production at Plant No. 124 in Kazan, which required great effort from designers, engineers, and workers. The development of the TB-7 began as an initiative of the Design Bureau under the leadership of Andrei Tupolev. In the mid-1930s, the Soviet Air Force formulated requirements for a new heavy bomber that was to combine high speed, long range, and the ability to operate at high altitudes. The AN-T-42, the first prototype, was created in response to these demands. Its design envisaged the use of the most advanced technologies of the time: a metal fuselage, powerful engines, and modern armament. However, the first aircraft was only the beginning. At the same time, the AN-T-42 Doubler was being developed, an improved version that was meant to take into account the shortcomings of the first prototype and serve as the model for mass production. These two aircraft underwent intensive testing, during which design flaws were revealed and required refinement. Simultaneously with the testing of the prototypes, Plant No. 124 in Kazan was preparing for mass production of the TB-7. This enterprise had been chosen deliberately. It had been designed with the prospect of building heavy aircraft such as the TB-4 and TB-6 back in the early 1930s at Tupolev's own request. In April 1937, work began on the serial blueprints, which were to ensure the accurate reproduction of the aircraft's design and production. This process was complicated, as it required adapting experimental drawings into a serial format and aligning them with the technological capabilities of the plant. The Air Force set an ambitious goal. By May 1, 1938, industry was to deliver 5 serial machines, even before the tests of the Doubler were completed. This schedule reflected the strategic importance of the TB-7 for the Soviet armed forces, as the aircraft was to become the backbone of long-range aviation capable of striking deep behind enemy lines. However, reality turned out to be more difficult. By January 1, 1938, preparation of the serial blueprints had been completed only by 40%. Delays arose due to numerous changes being made to the design based on the results of tests of the AN-T-42 and the Doubler. These changes concerned both individual components and the overall concept of the aircraft. For example, defects discovered during tests required improvements to the center wing section, fuselage, and weapon systems. The designers had to balance between the requirements of the military and the technological limitations of production. The drawings had to be revised to ensure the reliability and effectiveness of the aircraft under conditions of mass production. Despite its relative youth, Plant No. 124 had significant potential. It already had experience in overhauling heavy TB-3 bombers and producing DBA aircraft, which allowed the team to master complex technologies. However, the transition to mass production of the TB-7 required a qualitatively new level of organization. The plant received modern equipment, including machinery purchased in the United States, such as boring machines, automatic machines for producing standard parts, and high-performance facilities for manufacturing blanks. This equipment made it possible to ensure the production of large series of aircraft, but mastering it required time and skilled personnel. After the first tests of the AN-T-42 and AN-T-42 Doubler prototypes, the designers realized that the TB-7 needed improvements for mass production. In 1937, based on the test results, many changes were introduced into the drawings to make the aircraft more reliable, easier to manufacture, and better in combat. These changes affected major components of the aircraft, its armament and systems, and became the foundation for further development of the project. In 1938, an important milestone was the review of the mock-up, which examined new solutions, including improved aerodynamics through modifications to the nose and rear sections of the aircraft. One of the main changes in the TB-7's design was the reworking of the center wing section. In the AN-T-42 Doubler prototype, this section had a sidewall, but for mass production, it was replaced with a spar rib. This solution made the structure stronger and easier to manufacture at the plant. In addition, a hatch appeared in the upper skin of the wing, which allowed fuel tanks to be removed without dismantling the wing, significantly simplifying repair and maintenance. This was very important for serial machines, as the Air Force needed aircraft that could be quickly prepared for combat missions. The fuel tanks were also modified. They were made lighter and reshaped for convenient removal through the new hatches in the wing. The fuselage of the aircraft was also significantly refined. The second section of the fuselage, designated F2, was lengthened by 400 millimeters, which made better use of internal space and allowed for the placement of equipment. In section F3, which affected aerodynamics, the size of windows intended for passenger and transport versions was reduced. This decision improved the airflow around the aircraft, reducing drag during flight. In the navigator's cockpit, the layout of equipment was changed to make it easier for the crew to work, especially during long flights at high altitudes. Another important improvement was the new engine cooling system. In the serial TB7s, separate cooling was introduced for each engine, which increased the reliability of the power plant compared to the prototypes. This change was necessary to ensure stable engine operation at altitudes where the TB7 had an advantage over enemy fighters. The aircraft's armament was also modified, although it remained similar to that of the Doubler. The serial machines were equipped with 7 HKA's machine guns and 1 Schwach cannon, which was considered sufficient for defense at the main operational altitudes, where speed and altitude gave the TB7 an advantage. In 1938, the designers focused on improving aerodynamics. One of the key innovations was the redesign of the nose section of the fuselage, where the so-called beard, a protrusion in the navigator's cockpit that worsened airflow, was removed. This change was presented on the second TB7 mock-up, which was shown during the mock-up review on December 20, 1938. The Commission examined new gun installations developed by Kartashkin, which were intended to improve both aerodynamics and combat capabilities of the aircraft. The nose installation provided for 3 Schkaz machine guns, while the tail installation had 1 Schwach cannon. These changes were approved, and the Commission decided to implement them in the serial TB7. To verify the effectiveness of the new aerodynamic solutions, it was decided to make additional modifications to the ANT-42 prototype. In particular, it was planned to cut off the beard in the navigator's cockpit, install new AM-35 engines, produce mock-ups of the new gun positions, and equip the navigator's cockpit for long flights at high altitudes. Provision was also made for installing a separate cooling system for the units of the Central Supercharger, ACN. All these improvements were to be completed by April 1, 1939, for the aircraft's transfer to tests at the Air Force Research Institute. These measures were meant to confirm that the new solutions indeed improved the TB7's characteristics, particularly its ability to operate as a high-altitude bomber. These changes reflected the designer's determination to make the TB7 both combat-ready and suitable for mass production. Every modification was carefully analyzed, since the aircraft's ability to fulfill the Air Force's tasks depended on it. For example, reducing the windows in the F3 fuselage section was a compromise between passenger functions and combat effectiveness, as the Air Force demanded maximum aerodynamics to achieve high speed. Similarly, the new design of the fuel tanks and wing hatches corresponded to the need for quick maintenance, which was critically important for operation in field conditions. The plant began operations in 1934, although construction was still ongoing, which reflected the ambitious plans of the aviation industry. Despite modern equipment, the plant faced limitations due to unfinished construction. Production facilities needed completion, and supply processes required adjustment. Nevertheless, the workforce already had experience with heavy aircraft, particularly through overhauls of TB-3 bombers and mass production of the DBA. This experience became the foundation for mastering the TB-7, although the new aircraft demanded a much higher level of technical discipline. The plant was also preparing to produce another project, the MG aircraft, which added pressure on production resources. However, the enterprise's infrastructure, created for large series, gave confidence in the ability to establish TB-7 production provided that other issues were resolved. One of the main obstacles was the shortage of qualified engineering personnel. In the 1930s, the Soviet aviation industry faced an acute deficit of specialists capable of working on complex projects. The older cadre with experience in aircraft design and production was small in number, and many had fallen victim to the repressions of the late 1920s and early 1930s. The new engineers, graduates of the MAI, were only beginning to gain experience, and their training did not match the complexity of the tasks associated with the TB-7. This aircraft required deep understanding of aerodynamics, structural strength, and mass production technologies, which was a challenge for the young specialists. To overcome the personnel shortage in 1934-1935, a group of engineers from plants within the GUAP system was sent for training in the United States. This group was led by Grigory Ordzhonikidze, and among its members were such notable figures as Andrei Tupolev, Petr Dementiev, Sergei Leshchenko, and Boris Lisunov. Engineers from Plant No. 124 also took part in this program, gaining access to advanced American aircraft construction technologies. The training aimed to familiarize them with new production methods and prepare personnel capable of realizing complex projects like the TB-7. However, these efforts were largely undermined by the purges of the second half of the 1930s, during which the aviation industry lost many valuable specialists. Repressions affected both experienced engineers and young specialists, creating additional difficulties for the plant. Despite staffing problems, Plant No. 124 demonstrated readiness for heavy aircraft production. Its workforce consisted of young but ambitious employees who quickly mastered new technologies. For example, the experience of repairing the TB-3 allowed engineers and workers to gain expertise in working with all-metal structures, which was critically important for the TB-7. At the same time, the plant had to adapt its processes to the specifics of the new aircraft, which was distinguished by structural complexity and high-precision requirements. This demanded technical equipment and strict organization of labor, which was difficult under conditions of personnel shortages. The strategic importance of Plant No. 124 lay in its potential to become the main base for heavy bomber production. Tupolev, who had insisted on creating this enterprise, saw it as the center for realizing his ambitious projects. The plant's equipment allowed expectations for large-scale aircraft production, but full realization of this potential depended on solving organizational and staffing issues. For example, the TB-7 required stable supply of components, particularly engines and central supercharger units, which became a separate challenge. Staffing difficulties also affected cooperation between the plant and the Design Bureau, OKB. The designers developing the TB-7 needed close collaboration with production workers to ensure manufacturability of the design. However, the lack of experienced engineers at the plant complicated this process, forcing the OKB to take on additional functions of coordination and training. All of this unfolded under the strict deadlines set by the Air Force, which demanded the rapid launch of mass production. To launch mass production of the TB-7 at Plant No. 124 in Kazan, modern equipment, infrastructure, and clear organization of work were required. For this difficult task, a special group of technologists was created under the leadership of Professor Sivalnev of KAI. They developed the technology for manufacturing aircraft parts and for assembly. This stage was very important for stable production of the TB-7. The involvement of OKB designers, modernization of the plant, and rapid resolution of production problems accelerated preparations for mass production. The group of technologists headed by Sivalnev was created to adapt the OKB's blueprints, received in 1937-1938, to mass production conditions. They had to create detailed technical processes that would allow complex TB-7 parts to be produced with high precision and speed. The standardized technology provided for unification of production operations, which was critically important for ensuring quality and speed of assembly. This technology covered all stages, from material preparation to final aircraft assembly, including production of the center section, fuselage, wings, and weapon systems. The work of Sivalnev's group allowed the complex TB-7 design to be transferred into a format suitable for mass production, taking into account the plant's limited resources and aviation requirements. To implement these plans, Plant No. 124 underwent reconstruction. Production shops were adapted to the specifics of the TB-7, which required installation of additional equipment and improvement of work processes. For example, assembly shops were re-equipped for working with large metal structures, and the blank production facilities received new tools for producing standard parts. The reconstruction also provided for improvements in plant logistics to ensure uninterrupted supply of materials and components. These measures were necessary since the TB-7 was very complex and any delays in one stage could disrupt the production schedule. A major role in accelerating preparations was played by the involvement of OKB designers. A group of specialists who had participated in creating the TB-7 prototype was sent to the plant together with I.F. Nesval. They were to provide daily support for production, solving technical issues directly on site. These designers knew the aircraft's features well, which allowed them to quickly respond to problems during assembly. For example, they helped adapt blueprints to the plant's capabilities and consulted workers on correct execution of complex operations. Such close cooperation between the OKB and the plant was an innovative approach that significantly increased the efficiency of preparations. In addition, the plant relied on the potential involvement of additional engineering personnel from other design bureaus. In particular, specialists who had worked under B.A. Sauke on the second prototype of the MG aircraft and its series were considered. There was also the possibility of involving engineers from Bolkhovitinov's bureau, which was engaged in the DBA series. By the time Nezval arrived in Kazan, Bolkhovitinov's bureau had completed production of 5 DBA aircraft, after which work on this machine was stopped in favor of the TB7, and the bureau itself moved to Moscow. This allowed plant number 1024 to count on additional resources in the event of large-scale TB7 series production. In 1939, production of the first TB7 series finally began. The main parts of the airframe had been manufactured, and the plant moved on to final assembly of the first serial aircraft. Components began arriving at the enterprise, although their supply was unstable, which created certain difficulties. Nevertheless, the technical solutions developed by Sivilnev's group allowed work to proceed at a normal pace. For example, standardized processes for manufacturing parts and assembling components reduced the number of errors and accelerated the production cycle. Despite the young age of the workforce, factory workers demonstrated the ability to master complex technologies, which was the result of previous experience with the TB3 and DBA. Continuous support of production by the OKB also played a key role. The designers helped resolve technical issues and participated in quality control. For example, they checked the compliance of manufactured parts with the blueprints and made corrections in case deviations were found. At the beginning of 1939, plant number 24 in Kazan began assembling the first serial TB7 aircraft. But the project faced serious problems due to the shortage of crucial components, special devices for high-altitude operation, ACN-2. These devices were the foundation of the idea of a high-altitude fast bomber, but they were in short supply, and then serial production stopped altogether. This threatened the entire project. In 1940, production of the TB7 was halted, but thanks to the efforts of pilots and changes in the leadership of the aviation industry, the program was revived with new M30 and M40 diesel engines. The idea of the TB7 was that the aircraft could fly very high, where it had an advantage over enemy fighters. For this, special ACN-2 devices were needed, which helped the engines operate in the thin air at altitude. But the Ministry of Aviation Industry never assigned a plant for mass production of the ACN-2. As a result, plant number 124 received only 4 such devices, manufactured at the CIAM Experimental Laboratory. In total, CIAM produced 6 ACN-2, 1 for the ANT-42 prototype, 1 for a spare aircraft, and 4 for the series. After that, CIAM categorically refused to make more, citing complexity and high cost. This refusal became a critical problem because without the ACN-2, the TB7 lost its main purpose as a high-altitude bomber and became an ordinary medium-altitude aircraft. The absence of the ACN-2 changed the prospects of the TB7. Without the ability to fly very high, the aircraft lost its speed and altitude advantages, making it less effective compared to other bombers. To this were added problems with the supply of the main AM-34FRN engines from engine plant number 24. In the second half of 1939, deliveries of these engines nearly ceased, which further complicated production. Amid these difficulties, the ministry decided to stop TB7 production, redirecting Nezval's design bureau to develop a dive bomber. This step reflected declining interest in the TB7 project among the country's top leadership, which likely considered it too complex and expensive. The situation was worsened by organizational problems at plant number 124. In 1939, the enterprise's leadership changed. Director S.S. Baranov, Chief Engineer A.D. Schitz, and Chief Technologist V.A. Tikhomirov, with whom Nezval had good working relations, left. The new director, M.I. Steinberg, and his team quickly established cooperation with Nezval, but the transition period affected the speed of production. By the end of 1939, the plant had produced only 2 serial TB7s with AM-34FRN engines and ACN-2, and also had parts for several more aircraft, of which only 2 were equipped with ACN-2. The remaining aircraft were without engines, which delayed their completion. Despite these difficulties, the Air Force continued to insist on the importance of the TB-7. In reports to the government, they proposed producing 10 aircraft in 1939 and 250 in 1940. Nezval confirmed the possibility of producing 10 machines in 1939, but considered only 150 realistic for 1940. These plans turned out to be overly ambitious due to engine problems and organizational limitations. As a result, by early 1940, plant number 124 had produced only 6 TB-7s, 4 with ACN-2 and 2 with AM-35 engines without ACN. These machines were transferred to the Air Force for use in a regiment in Ukraine, but 6 more aircraft remained at the plant airfield without engines. The reaction of the aviation community to the production halt was mixed. Industry and the Air Force sent letters justifying the need to resume the program. Especially important was the appeal signed by Markov and Stefanovsky in December 1939, addressed to Voroshilov. These letters gradually began to influence leadership, and in 1940 the situation changed. The NKAP issued an order to dismantle equipment for TB-7 production, which seemed to mark the final end of the program. However, in the spring of 1940, interest in the TB-7 revived, partly due to Air Force pressure and letters in support of the project. M.M. Kaganovich, who was considered responsible for the disruption of the program, was replaced by A.I. Shakurin. In May 1940, Nezval and Steinberg were summoned to a meeting with Shakurin, where a government decision was announced to resume serial production of the TB-7 with new M30 and M40 diesel engines. The M30 diesel, equipped with 4 turbochargers, was considered the most powerful aviation diesel in the world at that time. In 1940, it passed state tests, but due to a number of problems, it was withdrawn from series production. Work resumed before the war under the new designation M40, which had a takeoff power of 1,500 horsepower and a nominal power of over 1,000 horsepower at altitude. Unlike the ACN-2, the M40 used only turbochargers, without an additional supercharging system. In 1940, the first serial TB-7s began entering service, including in the 14th Aviation Regiment in Borispil. In January 1940, 1 aircraft took part in tests during the war with Finland but crashed due to pilot error. By May 1940, 2 TB-7s were being prepared for display at a parade in Moscow, but one of them, flown by the famous pilot Mikhail Gromov, crashed during landing due to landing gear failure. By the end of 1940, military aviation had received all the produced aircraft, but by June 1941, only 10 machines remained in service, and some of them were broken. When the war began, the 2nd Squadron of the 14th Aviation Regiment, which flew the TB-7, suffered losses from German bombings of Borispil. After that, the surviving aircraft were relocated to the rear. In July 1941, the 81st Long-Range Aviation Division was formed under the command of Mikhail Vodopyanov. The TB-7 formed its core. The regiment on these aircraft, which became the 432nd Long-Range Aviation Regiment, was based in Kazan, where 13 aircraft with various engines were assembled. The first raid on Berlin on August 10, 1941, ended in failure due to technical problems and losses. But the Pe-8 continued to be used for strikes on Königsberg, Danzig, and other targets deep in enemy territory. In 1941-1942, the aircraft were based at airfields near Moscow, and after the German advance, in Kovrov. Aircraft with M30 and M40 diesel engines showed reliability problems, especially due to high oil consumption during long flights. In October 1941, by Stalin's order, additional 400-liter oil tanks were urgently installed on the Pe-8s for the Berlin raid, which solved this problem. In 1942, the Pe-8s participated in special missions, including the flight to England to deliver ferry crews. In May 1942, a Pe-8 with AM-35A engines flown by Endel Pusep made a flight to the United States via Scotland and Iceland to carry Foreign Minister Molotov. This flight demonstrated the reliability of aircraft with AM-35A, which by then had replaced the problematic diesels on most machines. The crew was decorated for the successful mission, and the flight became proof of the Pe-8's capabilities as a long-range bomber. A special place in the history of the Pe-8 was taken by the use of large FAB 5000 bombs. In 1942, industry created a powerful bomb weighing 1,580 kilograms, capable of creating craters up to 24 meters in diameter. Designers developed a new suspension system since the bomb did not fit inside the fuselage. In 1943, the Pe-8 dropped FAB 5000 bombs on Königsberg, Mogilev, Orel, and during the Battle of Kursk, causing great destruction. A total of 13 such bombs were used by spring 1944. But the use of the Pe-8 in tactical operations, such as during the German advance on Moscow, led to losses due to effective German air defenses. By 1943, in the 746th Regiment and the newly formed 890th Regiment of the 45th Long-Range Aviation Division, there were 18 Pe-8s, of which 11 were combat-ready. They were most actively used during the Battle of Kursk and raids on Finland, but operations within German air defense zones caused significant losses. In 1944, a serious design defect was revealed. During a combat mission to Helsinki, the crew heard a blow in the area of the wing center section. Later, on another aircraft, a displacement of the lower chord of the rear spar was discovered due to the rupture of a tube made of special steel. This defect was caused by metal fatigue, which was little understood in the 1930s. The designers reinforced the structure, but for some aircraft the bomb load was limited to 3,200 kilograms. In March 1942, Stalin created the Long-Range Aviation Command, which the Pe-8s were subordinated to. But by 1944, due to strengthened German air defenses equipped with radars and night fighters, Long-Range Aviation Command began replacing the Pe-8 with American B-25s under the Lend-Lease program. Production of the Pe-8 was officially stopped in 1944, although stockpiles at Plant No. 22 allowed up to 30 machines to be assembled. In 1945, the Pe-8s took part in preparations for the Victory Parade, but a tragedy with aircraft No. 42811, when the destruction of a structural element killed 14 people, confirmed the seriousness of the design problems. By 1946, most Pe-8s were unfit for flight, and they were replaced by the Tu-4. After the war, several machines were used in polar aviation and as flying laboratories. The Pe-8 program ended due to a combination of technical, organizational, and strategic factors. Structural defects, the unreliability of diesel engines, and the appearance of more effective aircraft made the Pe-8 obsolete. But its contribution to combat operations and unique missions left a mark in the history of Soviet aviation.